In this series, we'll be making a horror game from the ground up and teaching you everything along the way. From researching, theorizing, and prototyping, to main menus, UI, and sound. Join me and follow along to become the master game developer you want to be. Hello everybody and welcome to creating a horror game from scratch. Last time we spawned our ghost in and had him move around a little bit. Well, this time what we're going to do is put some throwable objects in our quadrants, and then while the ghost is occupying a quadrant, it might throw one of those objects about. This will of course eventually be some of the evidence we'll be collecting, but for now we'll put it on the default ghost. So the first thing we're going to want to do is create a object that can be thrown around. The way I'm going to do this is I'm going to make sure I have nothing selected. I'm going to press Shift 5 on the keyboard to get the modeling mode. On the left hand side, I'm going to go to the cube grid. Again, make sure nothing is selected before going into the cube grid. And from here, we're going to go to a power of 2 and switch it to probably 1. Nah, we'll go bigger. We'll do 2, 3. 3 looks pretty good. And I'm just going to click somewhere random. So we'll just do like right here. I'll hit 1, 2, something like that. And then we should have our own little static mesh here. So this is going to be our object that we use to throw things about. So this will be the object we use to get thrown about. You can pretty much use this as a placeholder, like you could see this being like a paint can or something like that. In order to get access to this though, just like this door we created, we're going to want to go over here with it selected and right click the highlighted thing, so the selected object, and we're going to browse to the asset. Down here, we are going to click on it, press F2, and we're just going to call this Throwable object underscore placeholder. So now we have a throwable object placeholder that we're going to use when creating blueprints. So we can go ahead and delete that out. Now let's go ahead and create a blueprint. So head over to your blueprints folder, and this is going to be an actor. So within our actors, we can right click. We're going to create a new blueprint class, and I'm going to make sure I'm recording because I hate when I do that. And we're going to click on actor. We will call this throwable object underscore BP. And we're going to open that up. Once it's open, we are going to add a static mesh. We'll name it throwable OB underscore SM for static mesh. And on the right hand side, for our static mesh, we will type in throw, and it should pop up. Yep, our throwable object placeholder. And bam, look at that. We'll go ahead and compile and save. And we're going to have to do some stuff on the right hand side. The first thing we're going to want to do is make sure gravity is enabled. And right here where it says simulate physics, make sure this is turned on. We're going to go ahead and click on the mass kg button. With it turned on, 100 kg is way too much. If you know pounds, this is about 200 pounds. For kg to pounds, you can basically just double it. So we're going to go ahead and make this about 2 pounds. So all we got to do is go over here, turn this into 1 kg, and bam. So this is roughly 2 pounds now. And that should be all we have to do for now. So go ahead and hit compile and save. Now in our code, we made it so the ghost will either go the east path or the west path, which means we're going to need to put throwable objects in each of these because we don't know which way it's going to go. So go ahead and just start placing some throwable objects around like this. Go ahead and grab all 3 of these, hold Alt, drag, bring them over, it duplicates them. And now we got about 3 throwable objects in each of the northwest and northeast quadrants. Let's go ahead and make it so the ghost will now be able to see those throwable objects around it and throw one if it so chooses. To do this, what we're going to do is hit Control Space, and within our actors folder, we're going to open up Ghost 1 or whatever you happen to name it. What we're going to do from here is on our capsule component, we are going to right click it and we are going to add event on component begin overlap. Now, what this is going to do is anytime our capsule overlaps anything, this is going to fire off, which means we need it to only fire off when certain actors are overlapped. So in this case, the quadrants we created. In order to do that, under the other actor, we need to pull out and type in cast to quadrant BP, like that. So this will only fire, well, what's going to happen is regardless of what it overlaps, it's going to fire. But because we're casting to the quadrant, this will fail. Every time it's not the quadrant, this cast will fail, and therefore it's going to double check that we know that it is only working whenever we enter a quadrant. We're going to pull out of as quadrant BP, and we are going to promote it to a variable. And what I'm going to do is I'm actually going to name this variable by clicking on it and hitting F2. I'm going to name this current quadrant. Which, by the way, I'm realizing this should probably be done in the parent ghost because all ghosts are going to be doing this. Okay, that's fine. I'm going to show how easy this is to fix. Go ahead and delete this variable and then grab this, hit Control X so that way it cuts it. Compile and save so this goes back to normal. And then go to the parent ghost. Let's scroll down to the bottom here. Paste. Like that. Perfect. And continue what we were doing. We'll pull out of the quadrant BP, promote to variable, and rename it current quadrant. Do you guys remember why we're doing this in the parent and not we're doing it in Ghost 1? The reason is because this means that this will be passed down to every single ghost that is a child of parent ghost. So by doing it in the parent, all the ghosts will have access to this code. Now, they might not all use it because certain ghosts won't have the ability to throw objects because it is an evidence, but regardless, it's better to do in the parent so that way we don't have to code it the 3 or 4 times for how many ghosts that can throw things. I hope that makes sense. Anyway, what we've done is we enter a quadrant, we cast to make sure it's a quadrant, and if it doesn't, we don't connect anything. If it is, we set it to the current quadrant. Perfect. So now we need to do one more thing before we keep going here. We are actually going to right click above this or below, it doesn't matter, and create a custom event, and we're going to call this ghost event, like that. So we need to call this every so often. And what it's going to do is it's going to pick a random event. And that random event is going to check what the current quadrant is, which you can see here, and depending on the quadrant information, potentially do something. So let me explain that by showing. We're going to have right now the ghost event only be able to access throwing objects. So what we're going to do is anytime a ghost event happens, we are going to create another custom event called throw object. So if ghost event gets called, right now we're just going to do throw object. Eventually there's going to be more logic here. So right now it seems like a waste. It's like, why call ghost event when you can just call throw object? It's because eventually we're going to have a lot of logic here to pick one of these rather than just straight up throw the object. So it calls throwing the object. What we need to do is get the current quadrant and make sure it exists first. So what we're going to do is right click and type in is valid. Then we're going to scroll down until you see the one with the question mark. What this is going to do is it's going to take this variable, the current quadrant, and make sure it exists. Because if it doesn't exist and we tell it to do things based on the assumption that it does, we are going to get errors. So we need to make sure it exists before we tell it to do things with it. That's all that's doing. So if it is valid, we are going to, again, get the current quadrant. And we're going to get overlapping actors like this. And for the class filter, we can type in throwable object BP. So this is going to get all the potential throwable objects for us. And we're going to get a copy. And what we're going to have to do here, actually, is a little bit of math. So all I did was move this around a little bit, so it might look slightly different. It's exactly the same code, just slightly moved around. The first thing I want to do out of overlapping actors, I want to pull this out, and I want to type in the word length, okay? And the reason we're going to do that is because we want to roll a random number here, but we have to make sure that random number doesn't go above the length of the array. So right-click and type in the word random, and we're going to scroll down until we see random integer, okay? And the max is going to be the length, like this, which I guess you pull this up like that. Depends on how you like it. For some reason, I think this looks better. It doesn't matter. Anyway, now we're going to pull out and we're going to type in the word get, and you're going to click on the one that says a copy. By now, you guys should know what that does. All we're doing is getting whatever actor we choose out of and getting a copy of it, which I don't know why it's called that necessarily, but that is what it's called. A little bit of cleanup there. And I plugged in the random integer into the get. So what this is going to do is it's going to get the current quadrant. It's going to get all the overlapping throwable objects. And it's going to do a random throwable object based on a random integer. And we're getting the length of the array to make sure the random integer doesn't go over the length. And now I need to check an old project to remember how I got objects to have momentum applied to them, i.e. be thrown. So we're going to move over here and we are going to open up, well, I'm going to, you don't have to do this, open up another Unreal Engine. I'm going to be opening up my project, Spirit Watch, which is available on itch.io, by the way, in case anybody wants to play it. However, fair warning, there is a game-breaking bug in the second level. Regardless, for now, let's go ahead and open up Spirit Watch. Okay, with Spirit Watch open, what we're going to do is we're going to move over to my Ghosty Boy right here. Because I believe it's the Ghosty Boy, the Ghost BP that I created, that has the information about throwing an object. So we have begin play, move player, ghost event. Oh, hey, look, see? So this is kind of the logic we're going to be using, by the way. You can see here. This just checks if it's hunting, which we probably won't have on. And then we'll just get a random integer and then do an event based on the integer that's drawn. But that's not what we're doing. We're here for this, throw object. So what we needed to do here is throw, delay. Okay, so let me break down what this is doing very simplistically, because we're not going to have to do all of this. Essentially, what this is doing is it's just throwing or giving the information to the object to throw itself. So in most circumstances, we're actually going to tell an object to do something to itself rather than have another object actually apply the code to it. An example of this would be if you're mining something in an RPG, the pickaxe isn't breaking the ore. The pickaxe is telling the ore to break. I don't know if that makes any sense, but let's continue and maybe it will. So we're just sending a throw event to the objects that can be thrown, which means we need to go to an object that can be thrown, like this gnome here. And let's take a look at our gnome. Get tossed. Okay, so pretty simple, actually. All we're going to do is set physics, linear velocity, and because we want it to be random, I basically said a random float range between all three of these, plugged them in. I want the static mesh to be thrown. Okay, perfect. So let's make this a little bit smaller, like this. And what we're gonna do is we're just gonna copy this. Oh, actually, you know what? I'm not gonna copy because you guys can't, because you don't have access to Spirit Watch. So let's do it. We need set physics linear velocity. Over here, type in set physics linear velocity, and the one you want is the one that says no, just kidding. We're sending a message to the throwable object, so therefore we wouldn't do it here. We need to do it in our throwable object BP. So make sure you open that up first, and from here go ahead and delete all that, and we're going to create a custom event, and we're just going to name it throw. Now we're going to right click and hit set what was it? Sorry. Set physics linear velocity. Set physics linear velocity, specifically on the throwable object static mesh, like that. Perfect. We'll plug that in. And then, as you can see, this right now does not look like what it does in my Spirit Watch. You can see right here, I got 3 little things. Here we just have 1. In order to fix this, we just need to right click and hit split struct pin. And then it gives you 3 nodes rather than 1 combined node. And then we got random float in range, anywhere from 100 to 500. So right click, random float in range. And we're going to do a minimum of 100 and a maximum of 500. And we're going to literally plug those into every single one of these. We're going to hit compile and save. And just like that, we have the ghost throwing our object in a random direction. So with that compiled and save, let's go back to the ghost. The parent ghost, and complete the logic we started here. So let's recap really quick. Get the current quadrant, make sure it exists, get its overlapping actors, specifically throwable objects, get a random with a maximum of the array's length, and that's where we're at. We're at get random of the length. So we've got a random object now. We're going to pull out, and believe it or not, we're actually going to cast to the throwable object BP. I thought this would be slightly cleaner, but it's not, and I'll explain why in just a moment. And then from the throwable object BP, we will do the custom event we just created called throw, which, as you remember, just applies random velocity to all directions. So we'll go ahead and hit compile and save. And the reason this isn't as clean as I was hoping it would be is because I was hoping, because we understand that it's a throwable object, we wouldn't have to cast to it first. But unfortunately, because we go through the random integer and then the get, it forgets that these are throwable objects, which is a little unfortunate. So right now, all the logic is set up. However, it is never, ever, ever, ever called. Right now, ghost events will not happen. So we need to create a system that will call the ghost event. However, let's do a little bit of cleaning up. If you have been following along closely, yours probably looks a little messy like mine. So we're going to fix that. Right now, I'm just going to grab my go down path. I'm going to create a comment, and we are just going to type in go down path. We're going to do some really simple comments for the time being just to get this nice and cleaned up. We're going to do this, type in ghost event, and then we're going to do this, throw object, and the final one here, we're going to do get current quadrant, which eventually we will actually delete out the current quadrant when it moves to the next, but for now, don't worry about it. So we're going to go ahead and compile and save. And now we need to figure out some logic to get the ghost to actually do events. And I think what I want to do is simply do this. At the end of the ghost event logic, we're just going to add a delay. And the duration of the delay will be a random float. So type in random float in range. We might need to move some of this. Oops. Come on now. Come on now. There we go. So we get a little bit more space here. And the random range will be, because right now we want it to happen super fucking frequently, we'll do a minimum of 1 and a maximum of like 5, and we'll plug that into the duration. So between 1 and 5 seconds, the delay will go, and then guess what it's going to do? Call ghost event. So basically this is going to be on a loop, right? And then this will just delay how frequent it happens, which means we only need to call it once, which will be right here. We'll go to the end of the event begin play and type in ghost event like that. So now what's going to happen is event begin play. Whenever the ghost spawns, it will start the ghost event. It will do the throw object, start delaying between 1 and 5 seconds, rinse and repeat until the end of time. So we'll compile and save, and now we're ready to test. What I'm going to do is I'm going to hit play and just immediately go to the camera and figure out where the ghost is at, and we will watch it throw some stuff about. So we'll hit play. We'll go to the camera. We'll see it's over here. Let's see if it actually throws something about. It's not. It's not throwing stuff about. So let's figure out why. So we got some errors. But it has complex as simple collision. So we need to reverse that. So let's go ahead and work on reversing that. However, what also happened? Access none trying to read property, call function array, get item 4. Oh, this is because we don't have an end to the ghost path yet. So these bottom 2 errors can be safely ignored. This stuff up here at the top is important though. Complex as simple collision. Let's change that. So what does it mean? What it means is there is 2 types of collision in the Unreal Engine. In fact, I think there's like 4. But the one that it's currently using is going to be no bueno for what we need. What we're going to do is hit Control Space and click on Content so we have all the folders visible. Under Search Content, type in Throwable Object. And we want the placeholder, the actual static mesh. Go ahead and double click on it. And from within here, on the right hand side, we need to figure out where, here it is. If you scroll down just a little bit, you'll see the collision complexity. Right now it says use complex collision as simple. So what we want to do is the opposite, is use simple collision as complex, and then hit save. Now, when we go back and we test, which I'm going to press Shift 1 to get rid of the modeling window, and go to the screen, first we'll figure out which one it went. It went this way. It should work. It's continuing to not work. Let's see if we got any errors. No errors this time. So we know we have fixed the collision issue. The problem now is coming from... Actually, I think I might know. Are these in the ground? No, they're not in the ground. Okay, be right back in a moment. Okay, I found the problem. If you go to your parent ghost on the throw object, it's because I was casting. So that is not going to work for us. So instead, what we're going to do is we are going to create an interface which will work just as well. Hit Control Space. If your search is still there, clear it. Go into your blueprints and go to Interfaces. In fact, we already have one. We have the interactable interface, which is going to work just fine. Oh, no, it's not, because we don't want the player to be able to do it. We just want the ghost to be able to do it. So right click, go to Blueprints, and then click on Blueprint Interface. And we're going to name this, for now, we'll just call it Ghost Interact. Okay. Go ahead and open that up. And we're going to name this function Ghost Interacted. And we are going to check call in editor. And we are going to compile and save and close the Ghost Interact interface. Then make sure your throwable object BP is open. Go to your class settings up here. Click on it. On the right-hand side, we are going to add the Ghost Interact interface, and we're going to compile and save. Once we've compiled and saved, simply right-click, type in Ghost Interacted. Oh, sorry, spelled it wrong. And you're going to go to Add Event, Event Ghost Interacted, like this. From here, pull out and go to your custom event named Throw. Compile and save. Go ahead and close that. On the parent ghost, now we're also going to go up here to the class settings. Actually, no, I lied. We don't got to do that. All we have to do now is from isValid, pull out and type in Ghost Interacted. And in this case, we just need the message, like so, and plug in our get to the Ghost Interacted message, compile and save. And that should make it so it works. Let's hit play, go to the security system, and it should be able to throw objects now. I've had a number of bugs. I'm not sure what I left in and what I didn't, but right now the current solution is, check it, there's just no collision on our throwable object ever since we switched it. So what we're going to do is, again, click on content, type in throwable. Let's get our placeholder. And yeah, there is currently no collision. See, we can't remove collision because it doesn't exist. So all we're going to do is simply click on Add Box Simplified Collision. And you'll see the little green outline indicating the collision it just created. Go ahead and save that. And I'm hoping that should fix it. Will it now do anything? Hey! It is now throwing objects just how we want it to. Fan-freaking-tastic. Doesn't that feel good to finally get this stuff working? Oh my god. Thank you guys so much for supporting this series. It has been doing amazing. Like, comment, and subscribe if you're enjoying it. If you dislike, please let me know why to help improve these tutorials. If you want to support me, the Patreon is down below. Again, thanks so much, and I'll see you in the next one.